His security, instead of really carrying a blanket or a stuffed animal, was this number one in this puzzle. I guess we had gotten him this puzzle because he did show an extreme interest in numbers from, as I recall, the age of 9 months. You can see it's very well gnawed and chewed and all the paper's worn off.
Eventually, I carried the number one around so much that it wore out, and my parents had to buy a new puzzle for the new number one.
He just keep asking questions, keep asking for problems, math problems.
Although he's very much interested in the math and science, but I think, in my opinion, he's not a nerd.
We don't believe we have the kind of IQ that our three sons do. And somehow her and my combination created this little monsters.
Okay, about a minute and a half. Everybody have everything they need? As with yesterday, the clock up here will be the official time. Good luck. The Olympiad examination takes place over 2 days. The students came yesterday morning and worked for 4.5 hours. We download the problems from the internet. They're released all across the country at the same time. There are 3 problems, and they have 4.5 hours to work on those problems. And then they come back today and they do it again for another 4.5 hours, so that they have a total of 9 hours of examination to do 6 very challenging and very difficult problems. Students that are able to perform at this level have the ability almost to sort of disappear into a zone. They're able to focus and concentrate and exclude all other environmental considerations.
It's a good feeling when you finish the problem, but also when you're working on it, it might not look like you're entertained, but I think I'm entertained. This is what I think of as a good time. I guess it's some kind of escapism. When you're working on the problem, that's the only problem.
My family's from China, and I moved with them to Canada when I was 3, and we moved to the US when I was 5. I remember my parents teaching me how to write the numerals, and I always write 5 and 7 sort of backwards. So I guess it didn't really come so naturally to me.
The math book in the States were a little bit too easy for him. So we bought textbooks from China, just teach him at home for each grade.
My father, he's a chemist. He always taught me chemistry when I was young, and it sort of laid the foundation of my interest in science. In middle school, I did a contest called Math Counts. It really got me interested in learning more about math.
He has a remarkable ability to reason abstractly. He's probably become more fluent with the language of mathematics than any other student that I've ever worked with.
There are 5 science Olympiads in the world, and that's biology, chemistry, physics, math, and computer science. Yi-san had made it to the finalist of all 5 categories in the nation.
He's basically the guy that wins all the awards and everything.
Everyone who takes math competitions, all their parents go oh, Yi-san's so good, why aren't you more like him?
He's the person we're all expecting to win because he's really good at this sort of thing.
Once I asked his mom, I said, well, Yi-san is so bright. You think you're just pure lucky, or it's because of your gene? And very humble, his mother replied, it's because I'm lucky.
Okay.
How does this part work? First of all, I don't bet triple words, and second of all, B is less than
In other words, triangle A.
I always think the most difficult thing in problem solving or doing pure research for this age, the problem gets so hard. 1 month, 2 months, people can hang on with it. But after a while, they find it very discouraging and they give up. If you have 10 or 12 students working on them together, they don't feel that way.
Can C be bigger than B? Is this possible?
Yeah.
Yeah. I like the formality of it, how there's a right answer, but at the same time, there's also nicer ways of getting to the right answer. Sometimes the search for the right answer, but also sometimes the search for the right way to get to the right answer. In 5th grade, they let me start algebra when most people didn't start till 7th grade. I heard about Exeter, and I decided to come here instead. And here I met Mr. Feng, and he's helped me a lot.
Basically, it's an inductive process.
Mr. Feng is much more into the individual work, not just giving people the answers and making people work through it.
If you guys are working hard, actually, you might have remembered, I actually give you this number 10 in one of your math Olympiad tests.
Can I see 6?
How come on number 6?
What I want to get out of math is to learn how to think. That's when I feel math is really useful and want to really work on it.
He is a very tremendous original thinker. So if the problem is about combinatorics, it's about playing a game, what's the best strategy, a graph theory, those kind of problem, he can give you very original method. So that's his strength.
Minus 2h squared minus k minus 2h.
I like those problems where you need very good insights instead of technically doing brute force equations for 2 hours. When I get one of those insights, that's when I feel really good about myself and doing mathematics.
Ryan is a very special talent. He is extraordinarily quick. I was surprised by his speed.
He's really good at thinking of really nice and elegant ideas for math. Sometimes he'll just draw points or lines out of nowhere, and they just immediately solve the problem. And it's like, how did you do that? And he's like, it's obvious. And it's not very obvious, but that's really cool.
He was 6 months. I got a new calendar. The calendar has baby pictures. When he saw the calendar, he had a big smile, but he didn't like babies. He liked the number. He took part in math competition in Korea. He got the first place among 4th graders nationwide. And he was a 7th grader. We moved to America.
Taeyeon is hard for Americans to pronounce and read. So my dad asked for a suitable English name for me and my brother. So we got one each. And that's Ryan. This is a completely new environment, completely new culture.
And I felt like I didn't belong here at all. And it was strange because in Korea I used to be on top of the things. But when I came here, I'm suddenly at the bottom of the ladder. I had little background in English, and I had probably less than kindergarten level vocabulary. Well, one thing I was still good at was math, because I don't really need to talk in order to be good at math. I just need to write stuff and numbers. I think by doing some math competitions, I got back my confidence. And after that, the transition to this world was very, very easy for me.
His character is a little changed. He learned how to get along with people, so now he can make friends easily.
So I'm impressed. You guys got it. So that's very good, right? So, that's why I never underestimate you guys. Every year, the one way I can measure my team is how much better each one of them are better than me. If they are much better than me, I know I have a very strong team.
Hi, Yi. Hi. Congratulations.
Thank you.
It's not often I get to deliver this kind of message in person.
Yeah.
This is Elgin Johnston.
Oh, nice to meet you.
Elgin's the chair of the Committee on the American Math Competitions. We just finished the grading about, 3-4 hours ago. I'm glad we were able to make contact with you, and you're one of the USAMO winners, one of the top 12.
Thank
so
you.
Congratulations.
Very nice
We'll
job.
see you again in Washington in about, 3-4 weeks, I guess.
Yeah.
Maybe a little over a month.
250,000 students in the United States take the AMC-10 and the AMC-12. We'll have 12,000 who take the AMY, 440 take the USAMO. We can take the top 12 papers, those become the USAMO winners. You've gone all the way from 250,000 kids who are the best kids in the high school anyway, down to 12 through this intensely competitive process.
We now present the winners of the USA Mathematical Olympiad Medal.
Yakov Burchenko-Kogan, would you and your mother please come to the podium?
I think it's very good that he is good at something and then he can meet other people. It gives something interesting in his life. Of course, he hopes that he will get into the team.
Yi Han, Tae-Hun Ko, Brian Lawrence, Kedrick Leung.
Math is all about exploring and trying new methods and techniques.
Richard McCutcheon, Yi Sun, Arnav Tripathi, Alex Zhai, Cherry Gong.
I like everything about mathematics. Like, I appreciate the elegance of proofs. Just the sheer power of it is also really beautiful.
Actually, for the problems she's doing, like those kids doing, many professors even cannot do it.
Math competitions are great. They introduce all these new ideas and in particular give students who are in school the first chance to see how you can be creative in solving a problem, because you're asked to solve problems that are unlike anything you've ever seen before, and so you have to develop a new way, a new technique to you. I mean, of course it may not be new to the whole world, but at that moment it has to be new to you because you've never seen anything like it, and that's really exciting. Girls are still by far the minority at the IMO. I mean, I remember actually in Taiwan, they tried to have some sort of dance as part of the IMO program, and it was less than 20% girls, and so this was an utter disaster. Being the first female, and I feel like people kept looking at me, and I had to represent all the females. This is what women are. This is what women who can make the IMO team are like. It's definitely worth it, and I've been so excited to see in the past couple of years the U.S. has had 2 more women on IMO teams.
The American Mathematics Competition started in 1950 with a competitive test in the New York section of the Mathematical Association of America. It has grown considerably since then.
I'd like to present the Clay Olympiad Scholar Award to Brian Lawrence of Kensington, Maryland. It honors the solution to the USA Mathematical Olympiad problem, which is judged most original.
Math is a beautiful creation in itself. It's a human achievement, it's an art. In a sense, it expresses an absolute truth that science doesn't.
I basically picked 6 medium problems. Maybe 2 of them on the easier side of medium, 4 of them on the harder side of medium. I told them the only thing I want to see on the TST is to really use these problems to magnify their difference. I tell them the hardest problem on a team selection test will not be as hard as the hardest problem on IMO. In a certain way, it's very brutal because there's no easy problems to lead them, to make them feel comfortable on the test.
4.5 hours doing math, it would kill most people. Literally, I guess. Brain dead after that.
I just like that clicking part of math. I could feel that my brain is actually working when those things happen. If I do well on the TST and go to Slovenia, then I'm pretty sure I can do well in the team. So I guess it all depends on the TST.
For the TST, that's kind of special because you have to think really hard. It decides whether you're on the team or not. And you have a lot of pressure in there too. I first got interested in contest math in 6th grade when my teacher introduced me and my parents to Math Counts, which is a middle school competition. I think it was the first time that I sort of discovered really the subject of math instead of being taught random stuff in school. That's basically how I learned, just by reading and working on problems that I thought were interesting. I was born in Nanjing, China. I came to the US when I was 2.5 to Pittsburgh.
When he was 6, 7 years old, he enjoyed doing mental calculation, like addition, subtraction, multiplication, things like that. And he also enjoyed discover the patterns of the numbers. Like he found the difference between 2 consecutive numbers. Square is the addition of these 2 numbers. He liked to think a lot of things, like think deep. But I think most kids at his age don't think that much as he thinks. So in that way, he's a little bit lonely.
There's a lot more theory about continued fractions before you get there.
Continued fractions. Since people at my school don't really, I don't think anyone there really has the same interest in math, so you can't really connect.
He always so in the math world, thinking all the time. So sometimes I just try to get him out of the house and then do something.
If you're working on a problem or set of problems for a long time and you sort of start to figure out the structure and then finally you get it, then I think that's a very rewarding part of math in general. To me, math is more of exploration than knowledge, I think.
Okay, guys, we're done.
This is not a line.
Yo, that
I
means
do not concur.
that means PBQ. That means
you draw that line.
That's not.
I drew the diagram wrong. Wait.
That means PBQ is collinear.
Sorry, I lost my diagram.
Yeah,
Right?
that's not.
Everybody sort of has a sense of how well they've performed. They know how the scoring goes. They have a good sense of, I really nailed that problem. I should be able to get 6 or 7 points out of it, or wow, I hardly made any progress at all. I'll be lucky if I only get 1 or 2 points.
What? At worst, it's 5 points. They don't get 5.
Yesterday, I totally screwed up. I think I woke up a bit late. I was really tired, and I just wasn't doing very well.
Even if I got only 1 problem that day, I would still be in pretty good position. So I guess that might have helped me think more clearly, and then I finally got it.
Misreading a question when there's 3 questions is not the best thing to do in the world.
That's exactly why we have this team selection exam, is to train these students how to react after a bad day.
Like, I wonder if they'll choose me and they'll say, like, he can't write solutions, but we can teach him that.
It's tough. I mean, it's an intensely objectively competitive field. Your worth is measured by your success, and so I think there's sometimes some real complex play of emotion. It's a lot like the Olympics. You can be a world-class competitor, but to make the Olympic team is special. Same thing happens here.
I didn't really see myself not being on the team unless I just had a severe case of panic attack or something like that, which I actually did. The night before the second day of the TST, I couldn't sleep. Like, I did not sleep at all, which was rather perturbing.
The most interesting thing was Halloween candies. He would collect the candies, and the following year the candies are still at home because he is sorting them by colors, sorting them by shapes, all the time sorting.
I was actually born in Lansing, Michigan, so I'm an American by birth, but I spent most of my life in North Carolina. I moved there when I was 3 because my dad got a job at UNC, I guess.
By the time 8th grade, there was nothing for him, because all the high school courses are by the 7th grade, he has finished all. So from 9th grade onwards, he started taking classes at UNC, math department.
He is doing his part. We never have to tell him when to study, do your homework, never had to do that. And I quit my job just to be able to take him back and forth from school to university and all that. Many parents, we talk about, oh, nowadays the children are so competitive, or we make it competitive for them, I don't know. And they do get stressed out. But I don't see that in Arnab or his friends. They recognize each other's strength and really respect that.
I play classical music quite a lot, and that's what I consider my other great love besides mathematics, because I've played music since I was maybe 5, maybe younger, but it's definitely been for a long time.
When I hear Arnab playing piano, then I tell him, I don't think he's that good in math. He touches your heart, your soul when he plays the piano. He should go to piano.
See, the music is really much more emotional. It's not intellectual for me at all. Whereas with math, you can't really do math emotionally. That doesn't make sense.
He uses maybe piano or music playing to unwind himself. When he's doing some serious mathematics, and he will come back and play the piano, maybe it makes him feel good, makes him feel relaxed.
And he comes back and plays a piece with more emotion and more strength, more love. And the funniest thing is that every time before an exam or something, he will play the piano.
We probably have not seen the best of him yet. The best of him is yet to come.
After the second day, everyone went to watch a movie. I guess it was a mindless action movie, so pretty good for forgetting about the test. And then by the time we got back, there were only, I guess, 2 hours to wait.
Each problem is given 7 points, and there's 6 of them. And right now, I believe downstairs, all the graders are discussing whether this guy should merit 6 points or 7 points or 5 points or 2 points or no points. It's just essentially 6 problems, even though there's a possible 42 points.
My guess is that it's an indexing error. So I really want to give this a 6.
Let's give it a 5 for the moment.
Okay.
And if there's a tie, then we rediscuss it. Okay.
You can decide whether the solution deserves to be graded from the bottom up or the top down. From the bottom up, you start giving points for things that they did that were right. And that implies that in general, the problem was not particularly right. In the top-down approach, you're taking points away from 7. You're saying that their solution was very close to a full solution and there were just some things wrong with it. We spend a lot of time discussing even, what is that word that they wrote there? We can't work out their handwriting. Or do you think they really meant this instead of that?
He's off by n-4/2.
Could change that, but it's possible that some of them are already different.
But you're not entirely sure that
Right,
it's
I'm not.
an
Well,
arithmetic mistake.
I'm. Okay, let me put it a different way. This sequence of computations certainly can yield you the right answer.
Yes, I agree.
And if he did them properly, he would have gotten the right answer.
We had some discussions about particular papers that affected the few team members who were right on the border. But in the end, we had a division between the top 6 and everyone else. And we announced them that night, as pretty much as soon as we knew.
Wow.
Okay, sounds good. We have our team. Okay, so we had a good TST this year. I think you guys did well. Particularly on the second day, we had lots of people solving 2 problems, which is always good. It was nice. But that's not probably what you're here for. The 2006 US IMO team in alphabetical order. Zach Abel. Zeb Brady. Ryan Coe.
Yeah, Ryan.
Yi Sun. Arnav Tripathi.
Yeah! I made it! I'm happy now. Oh wait, don't know who the 6th person is, right?
And Alex Chai.
Sitting there was kind of nerve-wracking because Alex was sort of prolonging the announcement as long as possible.
The alternates, the first alternate is Bohua Zhen, and the second alternate is Tedrick Wang.
I was pretty sure I would not make the team because I knew that I made many mistakes. And if you go in there thinking that you're not going to make it, it's not going to hurt you as much because you prepare yourself for the fact that you're not going to be there.
Well, I was traveling back to Exeter for my graduation. So while we were in the airport, I called someone back here and asked him, and then he told me the results.
These things are very close often. We have 12 problems to divide them, and one might hope that that would be enough, but a lot of the students cluster around the point where we have to draw the line for the top 6 to make the team.
I wasn't really disappointed with how I did because, even looking at the problems afterwards, I didn't think to myself, oh, I should have gotten those.
I had a good chance of making the team, but, it's always the competition, so I missed it. I'll try again next year, and I still have 2 years to go.
Since 8th grade, I was like, okay, I'm going to make the US IMO team some year. And when it finally happened, I said that I knew I had a pretty good chance coming into this, but I was really happy when it happened, that I finally made it. This was what I've been striving for quite a long time.
I called everyone I knew. I called my family and a few of my closest friends, and they were all excited. Although I think my brother was most excited of all, and possibly even more so than myself. He was bouncing off the walls. I think literally I heard a few crashes. So yeah, it was a nice surprise to make the team. I've been told I can see diagrams in a way that most people can't. In geometry, that's very concrete. You can literally look at a problem from many different angles. I guess my interest in math started around 7th grade. I was always good at math. I have faint memories from like doing exponents in 3rd grade and stuff. From 8th or so on, most of the math I've learned was not through school. It was through reading books and just independently learning whatever I could. So my dad is a psychologist, self-employed. My mom is a lawyer. She works for Bank of America. Neither of my parents has that mathematical side of the brain.
Matthew's a year older than Zach, and they were in the same high school. Zach would sit there and just get award after award at these assemblies, and Matt was his biggest fan. He was his biggest supporter. He would say, I have a math tutor in the room next door to me. There's nothing to complain about here.
Some people think that people who are so good at math are just nerds and they're whizzes and that's all they know how to do, and Zach has never been into that category at all. He's always played sports. He won a conference championship in pole vaulting, and he's always been completely outgoing and willing to do anything. He just happens to love math. He's always shown me a different way to look at math, a different way to open it up. It doesn't have to be straight out of the book. There's more ways to go around it. There's more ways to look at it. Well, he's a great brother.
We would have to pretty much ask him to stop doing math and finish his homework sometimes, just because that's what he would prefer to do. So yes, his friends, everyone would say he's a genius at math, but they really didn't see how hard he worked at it and continues to work at it all the time. It's just what he's passionate about.
I worry about him being a perfectionist. He can be good, he doesn't have to be great. I worry more that he stresses himself out trying to be so perfect, when it's okay to calm down and do well, do your best, and if it's not the best in the world, it's okay.
For a really cool problem, you can explain to anyone why it's cool without getting into the gritty details of the formulas and the calculations. I think math does that. It speaks for itself, and it's very beautiful.
We've now got 50 kids roughly at each camp, and there's the 12 kids in the black group of the USAMO winners and high scorers, and from that we select the team. And then the blue group is typically juniors and sophomores who have scored, say, honorable mention level on the USAMO. And then there's about 25 freshmen. I'm Steve Dunbar. I'm the director of the American Mathematics Competitions. Welcome to the University of Nebraska-Lincoln. The university is happy to host you here. With that, I want to introduce a few people in order. Some of the instructors are advanced undergraduates or graduate students in mathematics. They've all been through the IMO. They've all had, some of them, 2, 3, even 4 years of experience at the IMO. And they'll be doing a combination of grading and instructing.
I was at MOP 94, 95, 97, and I've been here twice officially other than those 5 times that I just mentioned.
Razvan Jelka, and I've also been here a couple of times. Yeah, I think you'll see me mainly for geometry.
Hi, I'm Oleg. I will be a grader here. I was a grader here last year. I was on the Russian IMO team in 2002 and 2003, and on the US team in 2004.
The deputy leader of the US IMO team this year, and I'll be one of the instructors teaching you. You need to remember that your primary purpose for being here at the program is to do math. And luckily, this is another thing that you can do with your friends.
I started coming to MOP in my 8th grade year, and that year was the first year I qualified for the USAMO. I was pretty surprised when I got an invitation to come to the camp because I thought it was only for the top 30 people. I was definitely not really close to the top of that group. This will be my 5th time, and this year I think I'm actually finally getting all the stuff and understanding it.
What we're doing right now is we have some of the graders, the younger faculty members, are working one-on-one with the students. A pair of graders work with a pair of students. And they're going to find out what the students' weaknesses and strengths are and talk to them, try to convince them to work on some problems that they maybe think they can't do, and show them they can.
AEB, which is...
You've lost me, sorry.
This angle, this angle.
We have individual tests. Normally every other day we take a 4 or 4.5 hour test. We have team tests with different groups. teams of about 6, and it really does help to have 2 or 3 minds bashing the same problem. You get different perspectives on the same ideas.
In the first week, for like the first 3 days, we were working on problems at night, like every day. It's not that easy to be thinking hard all day long. One of the best things about this camp is that you can sort of talk to other people, other kids. This is like one of the most fun parts of my year.
What I like about MOP is that it is very collaborative, that, you know, what's going on is that you've got a lot of individual people who come in here and they don't know a lot of math. You come here and you're sort of dropped into the deep end, and suddenly you're surrounded by people your age who know all these things, these wonderful things, beautiful, magical, amazing things that you never even imagined were possible. And then you begin to learn. You hunker down, you become a part of this community. And it's a personal journey. It's an individual journey. And, well, for me at least, it becomes a part of you for the rest of your life.
These kids discover that there are other kids out there who love mathematics, who want to do mathematics more than anything, who love to compete at mathematics, who love solving problems. And often these kids have been isolated in their high school. And they get together with 50 other kids in this intense 3-week pressure cooker, and they come out exhilarated.
In MOP 2 years ago, I probably gained more math skills in that 3 weeks than I did in the past 2 years. That's because I was able to actually gear myself to work. And in school or in other places, it's really hard. So I think the program really serves its purpose, as in to prepare people for the team.
So you realize that there are some people better at this, and some people better at this, and you are better at some other things. If you do very well tomorrow, good. You still have 6 more individual tests to go. If you didn't do well, it's okay. You know, you can even call me and cry with me. That's fine. I have lots of tissues. Okay?
So are you passing? Why do you start?
My name is Zarathustra Elisar Brady. And what people call me is my initials. My parents thought of that, and they were like, it's cool. My mom says, like, when I was little, I learned multiplication quickly, but I couldn't do the times table, so that sort of sucked. I actually skipped 2nd and 3rd grade.
One of the most important things that I notice about Zeb is his commitment. If you were to give Zeb a book on any subject or any task, and he would just diligently work on it. Sometimes he would spend 2 hours, and I would ask him, what are you doing? And he's like, well, I'm just trying to solve this problem. He's just focused. He doesn't give up. He tries all kinds of different approaches. He's going to be very hard sometimes on himself.
All right, see you on Monday. Adios.
I think I have a little bit of a distaste for schools, just from my own experience. So my philosophy was the fewer years he spends in school, the better it will be for him. He must have spent a total of 3 years in school by the time we moved out here to Los Angeles.
Is this what I think it is? I was born in Philadelphia. My sister was born in Georgia, and my other sister was born in California. So we move a lot.
What do you want on this delicious dinner?
He always talks about math. He doesn't do any work. All he does is just do math all day. Sometimes he cooks us dinner if he's feeling nice. And he eats a lot. He teaches my little sister how to do math. He's an okay brother. I wouldn't trade him for a new one. I'd like to upgrade him, though.
All right, Zeb.
Math hates me. I hate math. I can't do it. First of all, it's boring. Second of all, it takes so long for me to do math homework. Third of all, like other classes, like I can kind of just do them. But with math, I have to actually study if I want to do anything. So math just kind of sucks.
You have to allow a kid to recognize what they're interested in, and you have to be able to not enforce what you think is important on them. And that freedom will actually allow them to meet more of their potential.
Well, this is, have you tried this one?
Yes, I've tried that one.
His math teacher introduced me to him, and when I was talking to him, it became obvious like how much potential he had, how smart he was. He had some holes in his math education. If it was too straightforward or too obvious for him, he kind of skipped those, you know. So we had to work on those to fill those holes. And in coaching, there's this thing that I liked so much, especially students like Zeb, when they understand, their like eyes kind of shine and you see that they got the point.
I have this theory that the smarter a mathematician is, the less they work, or the less they like to work, but I don't know if it's true. See, I haven't asked enough actual mathematicians how lazy they are.
I'm kind of amazed at his energy. Like, he never seems to be tired or exhausted.
Really?
You come in here with all of that energy and all of that excitement, and you feed into it all of the things that we're going to teach here. And some people are just like a sponge. They take in what's given on the board and they say, please, can I have some more? And by the end of it, they've mastered all of the techniques that we have to offer.
We don't want to build this as a factory. You know, if you go to MOP for 3 years, you will automatically win a gold medal or silver medal. It's more about identify students' ability, train them to be more experienced, but the ability is their own.
I see this as being a program that sets a tone or a standard that says that, yeah, we can meet this kind of international level of problem solving and mathematical ability. We can do it.
There's a sense that these students are our students, they're American students, and they represent something about our
His security, instead of really carrying a blanket or a stuffed animal, was this number one in this puzzle. I guess we had gotten him this puzzle because he did show an extreme interest in numbers from, as I recall, the age of 9 months. You can see it's very well gnawed and chewed and all the paper's worn off.
We don't believe we have the kind of IQ that our 3 sons do. And somehow her and my combination created this little monsters.
Okay, about a minute and a half. Everybody have everything they need?
As with yesterday, the clock up here will be the official time. Good luck. The Olympiad examination takes place over 2 days. The students came yesterday morning and worked for 4.5 hours. We download the problems from the internet. They're released all across the country at the same time. There are 3 problems, and they have 4.5 hours to work on those problems. And then they come back today and they do it again for another 4.5 hours, so that they have a total of 9 hours of examination to do 6 very challenging and very difficult problems. Students that are able to perform at this level have the ability almost to sort of disappear into a zone. They're able to focus and concentrate and exclude all other environmental considerations.
My family's from China, and I moved with them to Canada when I was 3, and we moved to the US when I was 5. I remember my parents teaching me how to write the numerals, and I always write 5 and 7 sort of backwards. So I guess it didn't really come so naturally to me.
The math book in the States were a little bit too easy for him. So we bought textbooks from China, just to teach him at home for each grade.
My father, he's a chemist. He always taught me chemistry when I was young, and it sort of laid the foundation of my interest in science. In middle school, I did a contest called Math Counts. It really got me interested in learning more about math.
Okay.
How does this part work? First of all, I don't get triple words, and second of all, B is less than
In other words, triangle.
I always think the most difficult thing in problem solving or doing pure research for this age, the problem gets so hard. 1 month, 2 months, people can hang on with it. But after a while, they find it very discouraging and they give up. If you have 10 or 12 students working on them together, they don't feel that way.
Can C be bigger than B? Is this possible?
Yeah.
Okay.
Yeah. I like the formality of it, how there's a right answer, but at the same time, there's also nicer ways of getting to the right answer. Sometimes the search for the right answer, but also sometimes the search for the right way to get to the right answer.
Minus 2h squared minus k minus 2h.
I like those problems where you need very good insights instead of technically doing brute force equations for 2 hours. When I get one of those insights, that's when I feel really good about myself and doing mathematics.
Ryan is a very special talent. He is extraordinarily quick. I was surprised by his speed.
He was 6 months. I got a new calendar. The calendar has baby pictures. When he saw the calendar, he had a big smile, but he didn't like babies. He liked the number. He took part in math competition in Korea. He got the first place among 4th graders nationwide, and he was a 7th grader. We moved to America.
I felt like I didn't belong here at all. I had little background in English, and I had probably less than kindergarten level vocabulary. Well, one thing I was still good at was math, because I don't really need to talk in order to be good at math. I just need to write stuff and numbers. I think by doing some math competitions, I got back my confidence. And after that, the transition to this world was very, very easy for me.
So I'm impressed. You guys got it. So that's very good, right? So, that's why I never underestimate you guys. Every year, the one way I can measure my team is how much better each one of them are better than me. If they are much better than me, I know I have a very strong team.
Hi, E.
Hi.
Congratulations.
Thank you.
It's not often I get to deliver this kind of message in person.
Yeah.
This is Elgin Johnston.
Oh, nice to meet you.
Elgin's the chair of the Committee on the American Math Competitions. We just finished the grading about, 3-4 hours ago. I'm glad we were able to make contact with you, and you're one of the USAMO winners, one of the top 12.
Thank
so
you.
congratulations.
Very nice
We'll
job.
see you again in Washington in about, 3-4 weeks, I guess.
Yeah.
Maybe a little over a month. 250,000 students in the United States take the AMC-10 and the AMC-12. We'll have 12,000 who take the AMY, 440 take the USAMO. We can take the top 12 papers, those become the USAMO winners. You've gone all the way from 250,000 kids who are the best kids in the high school anyway, down to 12 through this intensely competitive process.
We now present the winners of the USA Mathematical Olympiad Medal.
Tae-Hun Ko, Brian Lawrence, Hedrick Leung.
Math is all about exploring and trying new methods and techniques.
Richard McCutcheon, Yi Sun, Arnav Tripathi, Alex Zhai, Sherry Gong.
I like everything about mathematics. Like, I appreciate the elegance of proofs. Just the sheer power of it is also really beautiful.
Math competitions are great. They introduce all these new ideas and in particular give students who are in school the first chance to see how you can be creative in solving a problem, because you're asked to solve problems that are unlike anything you've ever seen before, and so you have to develop a new way, a new technique to you. I mean, you know, of course it may not be new to the whole world, but at that moment it has to be new to you because you've never seen anything like it, and that's really exciting. Girls are still by far the minority at the IMO. Being the first female, and I feel like people kept looking at me, and I had to represent all the females. This is what women are. This is what women who can make the IMO team are like.
The American Mathematics Competition started in 1950 with a competitive test in the New York section of the Mathematical Association of America. It has grown considerably since then.
I tell them the hardest problem on a team selection test will not be as hard as the hardest problem on IMO. In a certain way, it's very brutal because there's no easy problems to lead them, to make them feel comfortable on the test.
4.5 hours doing math, it would kill most people. Literally, I guess. Brain dead after that.
For the TST, that's kind of special because you have to think really hard. It decides whether you're on the team or not. And you have a lot of pressure in there too. I first got interested in contest math in 6th grade when my teacher introduced me and my parents to Math Counts, which is a middle school competition. I think it was the first time that I sort of discovered really the subject of math instead of being taught random stuff in school. That's basically how I learned, just by reading and working on problems that I thought were interesting. I was born in Nanjing, China. I came to the US when I was 2.5 to Pittsburgh.
When he was 6-7 years old, he enjoyed doing mental calculation, like addition, subtraction, multiplication, things like that. And he also enjoyed discover the patterns of the numbers. Like he found the difference between two consecutive numbers. Square is the addition of these two numbers.
If you're working on a problem or set of problems for a long time and you sort of start to figure out the structure and then like finally you get it, then I think that's a very rewarding part of math in general. To me, math is more of exploration than knowledge, I think.
Okay, guys, we're done. Thanks.
That means PBQ is collinear.
Sorry, I lost my diagram.
Yeah,
Right?
that's...
I wonder if they'll choose me and they'll say, like, he can't write solutions, but we can teach him that.
It's tough. I mean, it's an intensely objectively competitive field. Your worth is measured by your success, and so I think there's sometimes some real complex play of emotion. It's a lot like the Olympics. You can be a world-class competitor, but to make the Olympic team is special. Same thing happens here.
I didn't really see myself not being on the team unless I just had a severe case of panic attack or something like that, which I actually did. The night before the second day of the TST, I couldn't sleep. Like, I did not sleep at all, which was rather perturbing.
The most interesting thing was Halloween candies. He would collect the candies, and the following year the candies are still at home because he is sorting them by colors, sorting them by shapes, all the time sorting.
I was actually born in Lansing, Michigan, so I'm an American by birth, but I spent most of my life in North Carolina. I moved there when I was 3 because my dad got a job at UNC, I guess. I play classical music quite a lot, and that's what I consider my other great love besides mathematics, because I've played music since I was maybe 5, maybe younger, but it's definitely been for a long time.
When I hear Arno playing piano, then I tell him, I don't think he's that good in math. He touches your heart, your soul when he plays the piano. He should go to piano.
See, the music is really much more emotional. It's not intellectual for me at all. Whereas with math, you can't really do math emotionally. That doesn't make sense.
If there's a tie, then we discuss it. Okay.
You can decide whether the solution deserves to be graded from the bottom up or the top down. From the bottom up, you start giving points for things that they did that were right. And that implies that in general, the problem was not particularly right. In the top-down approach, you're taking points away from 7. You're saying that their solution was very close to a full solution and there were just some things wrong with it.
This sequence of computations certainly can yield you the right answer.
Yes, I agree.
And if he did them properly, he would have gotten the right answer.
We had some discussions about particular papers that affected the few team members who were right on the border. But in the end, we had a division between the top 6 and everyone else, and we announced them that night. Okay, so we had a good TST this year. I think you guys did well. Particularly on the second day, we had lots of people solving 2 problems, which is always good. It was nice. But that's not probably what you're here for. The 2006 US IMO team in alphabetical order. Zach Abel. Zeb Brady. Ryan Coe.
Yeah, Ryan.
Yi Sun. Arnav Tripathi.
Yeah! I made it! I'm happy now. Oh wait, I mean, don't know who the 6th person is, right?
And Alex Chai.
Since 8th grade, I was like, okay, I'm going to make the US IMO team some year. And when it finally happened, I mean, I said that I knew I had a pretty good chance coming into this, but I was really happy when it happened, that I finally made it. This was what I've been striving for quite a long time.
I called everyone I knew. I called my family and a few of my closest friends,
and they were all excited. Although I think my brother was most excited of all, and possibly even more so than myself. He was bouncing off the walls. I think literally I heard a few crashes. So yeah, it was a nice surprise to make the team. I've been told I can see diagrams in a way that most people can't. In geometry, that's very concrete. You can literally look at a problem from many different angles. I guess my interest in math started around 7th grade. I was always good at math.
For most students who show a lot of potential in mathematics and who succeed in these kinds of programs, like the Math Olympiad, they show that talent at a very early age. The parents simply facilitate that, simply make it possible for students to participate.
Ever since he could talk, he started, when I was driving, he started watching the gas price at the gas station, comparing the change from day to day. And I go, oh, it was so boring. Every time I drove, he had to talk about gas.
Yeah, I started doing math competitions around 7th grade because I was taking a class called Math Enrichment. And in that class, all we did was like repetitive competition math problems.
We're the ones who drop them off. And we have to pick them up in 2 hours, 2.5 hours later. So a lot of us decided to stay there. And then we start chatting, and we become friends.
I would ask them age-appropriate questions. You know, I would ask my daughter, for example, how much is 63 divided by 9? And I would ask Matthew how much is 9 times 6, and then I would intend to ask Zach how much is 9 plus 6. And whatever I would ask them, Zach from the back seat would yell out the answer. His 7th grade teacher, Dr. Mindel, really pulled us aside and said he's like a sponge. I can't teach him fast enough. He basically took over tutoring him kind of one-on-one and became his mentor. And that's where Zach's interest in math competitions, he just soared from then on.
My biggest peer group has always been online. artofproblemsolving.com, founded by Richard Russick, I believe. I've been an active member on that for a few years now, just solving problems and general discussion in the forums. I think it's a great place for any aspiring mathematician to meet others just like yourself, just want to talk about math. And in fact, on that website is also where I learned most of my mathematics.
And mostly we have to, when we talk to Zach now at school, we have to ask him, now, you sure you want to take 6 classes? And sure you don't want to just take 5 classes?
Are you getting any sleep?
That's right. Are you sleeping? Are you eating?
In his 2nd grade, the principal of the school, he gave him special question like every week. After the week, he had to turn his work to the principal.
I used to joke about teaching Yi, but I use that word very lightly because he's as close to a mathematical genius as certainly I've ever met. He does it just because he loves it.
He has been participating in the USA Math Olympiad for the last 5 years. He already got awards in the different competitions of the same level, which is International Physics Olympiad. He got the gold medal in Korea.
My parents had taught me a lot of math during elementary school, so I guess I was accelerated. Definitely, I guess in high school, one of the big outlets is in competitions, but that's not really the most important area of math, I guess.
What is?
I guess research and sort of learning new things about it. Because in competitions, you're sort of rehashing what's known and what you can figure out. But while doing research, you actually try to find new things. But I guess through competitions, you sort of simulate that from what you don't know, but maybe someone else knows, but you try to figure it out again. And it sort of helps as maybe some sort of practice. But in the end, it's all towards finding new things.
What makes these kids sometimes, I think, so very bright and so good is their ability right from a young age of being able to concentrate very deeply. And that's why maybe they are able to understand things and explain things. And maybe because they're good listeners that we like to be with them.
Because I enjoyed math so much at a young age, my curriculum math I advanced pretty quickly, and by 6th grade I was taking pre-calculus at Chapel High School, where I met one of my really great teachers of mathematics, Mr. Bud Stewart, and also Mr. John Goebel. and at the School of Science and Math, also local to my area. And those two teachers really developed my interest not only in mathematical curricula, but also the mathematical problem-solving structure and all of that. I really developed into where I am now because of them.
He has finished all the undergraduate math classes at UNC, and he took 2 graduate classes in 2005.
So Arnav came to my office hours once a week. It was around 4:30. It was after high school. I would try to summarize the week of classes, and he got the highest score in the class. I think these Olympiad kids are kind of exceptional, and even if they were growing up in the middle of nowhere, they would probably still be good at math.
When Alex was younger, I think his teacher didn't quite get how good he is, how fast and how accurate he is, and how logical and how complicated he's thinking in math. So he's very, very bored in elementary school. So the first happy year is the 6th grade, because I asked the teacher, if you cannot teach him, just let him do whatever he wants. Then he ended up going to teacher's office and do independent study. And he's very happy because he just solved his problem. Mostly that year he did the math count problem. And I think math count problem also is a much better problem than textbook problem, because math count is competition, and the problem is a little tricky. Once he said all mathematics he learns from parents when he was younger. After that, I think he learned by himself.
My mom gave me some worksheets occasionally, or like problems she made up, just for like when I was little, simple stuff like factoring, things like that. But they didn't really teach me very much directly in terms of math.
I know many parents in this country themselves is a little bit afraid of math, or kind of had a bad experience in school. At least I heard online discussion, some parents said they not just women, like also men, including those fathers, they say they lost the interest in math because American math curriculum is so boring. I think it's at least partially true, because the textbook is so easy, so thick, but it's so little content. And the problem is so straightforward, like more like plug and play. They don't require much thinking. You don't do many steps, like at most 3 steps solve a problem. So it's not so interesting.
I don't know that my ability in mathematics created difficulties, but maybe my lack of interest in some of the things that other people like the popular music and the sports and so forth. And for a while, I mean, my excuse was always, I'm interested in math, so nobody liked me. But really, looking back now, I can see that I was somewhat nerdy. I think I'm less nerdy now. Maybe I'm just deluding myself and will think differently in a few years. But yeah, I think that I've been a lot happier at Blair, because there are some people who are really interested in math, and I can talk to them. But just in general, the people are more accepting of that, and I've learned how to just make conversation. That helps.
I remember I just stared at the ground because of the patterns that were woven into the tiles on like the floors of malls and restaurants. I just look at them and see what properties I could figure out.
Tedrick has accomplished things, and we've pretty much ignored it at the beginning. Like when he was in 6th grade, he took a placement test, and in the first time in the history of school, he aced all 3 sections, and we go, okay, he had a good day. I mean, that was our thought. I mean, we figured if he was really that good, the teacher will tell us, but little did we know the teachers really don't know what to tell us. They don't know how to motivate the kid either.
Over the years, school has been holding me and many others back.
School has?
Yeah. Like heavy schoolwork, you can't concentrate on math all that much. So it's really hard for people like me and others who seem really stressed to really excel in math as much as they want to.
He has problem getting up for school. Tedrick, we're talking about Monday through Friday. We have to drag him out of bed. Well, came Saturday, a couple years ago when we were going to San Diego Math Circle. No problem. Just tap on his shoulder, he's up.
Ready to go.
In our kid, I should say in our kids, because our older kid was really good in math also. Not quite at Tedrick's level, but in his own right, he was very good. But they are excited about math. They actually they both like to tackle math problems on their own. So as parents, now you're not pushing them, they're pushing you.
And we started working together with Tedrick and Zeb working together, and I was coaching them. We were basically solving problems together. And about Tedrick, he has very sharp mind, especially in geometry. Like, he was kind of just the opposite of Zeb. So geometry was weakest point of Zeb and strongest point of Tedrick. So actually it was a good experience for both of them working together on problems.
My parents are both math professors, so I guess I sort of have had like a lot of mathematically related ideas going in the background the whole time.
Like in the early ages, she is very interested in solving riddles. I borrowed some riddle books from the library and read to her, and she's very interested in that about 3 or 4 years old, even though she cannot count very well, like some genius.
When I was really young, my dad took me outside and we measured telephone poles with similar triangles by measuring the shadow lengths and comparing it to, like, finding the ratio with my shadow length.
The key isn't memorizing theorems and formulas and all of that. I mean, that helps, but the key is sort of thinking from scratch.
He did a lot of reading and solving problems just on his own, and asked me questions, and also we like to walk very much, and I tried to explain him things while we were just walking, and I noticed he's very quick. I mean, it took him, I could explain something once and he would already get it. So it was very pleasant to talk to him about math because he would just get it right away. So I think it is very probable that he will become a mathematician. I don't think it's a hope that I have this hope. I just see this as a most probable, and I think it's good. But if he decides suddenly to do something else and enjoy it, that's great. As long as he will enjoy what he's doing, it won't be just a job, but something more than that, I think.
Actually, last summer I did a research project in math, and I found a I think it's new formula for the expected value of something called the winding number. And what that actually means is, suppose you have a man who's walking on a grid, and every time step he sort of chooses one of the 4 directions to go in randomly. Then the winding number is how many times he'll rotate around a point. So I found on average how many times he'll do that.
I think I'm a good explainer, and some people have said that they can hear a teacher talk about something and they won't understand it, and then I'll talk about it and they get it. And I try to be very clear and precise, and also to explain things in a logical way so that people can see how to approach the subject, and I think that helps. So yeah, I want to teach in some form when I grow up.
That seems like that's what he's always wanted to do, to teach and to think of things and write about things that he loves. So I hope that he'll be happy and find some sort of employment somewhere in the world where he can continue to do that. So.
Yes, and I hope that he'll continue to find, with each new project that he's involved in or each new place that he goes, he'll continue to find at least 1 or 2 people that he can really talk with and really work with, and just build that up over time, so that he'll just have more people that share his interests, but also his kind of personality, which is just an enthusiasm and love of being helpful to others and that kind of thing, and not just the sort of competitive aspect of it.
I do a lot of my own work already. I don't know that it's so large scale or fancy that you could call it research, but for the past few years, whenever I found something in math interesting, I would investigate it and maybe write about it. At one point, I was investigating some stuff about vectors, and I defined a new operation that I called hash product, and actually that's become my internet pseudonym. It's Internet Unique, so that's what I call my accounts. I think what I find the most fulfilling is when I do something and someone else appreciates it.
He's so wrapped up and enjoys it so much, which I think is great. If you have something that early in life that you know you love, you know you'll always love it and always have something that will bring you a lot of joy.
When I do mathematics, I'm not thinking about what that's going to mean for cryptography or what that's going to mean for mathematical biology or all the myriad of ways that math is used. To me, mathematics is an art, and I'm studying this structure for its pure beauty and its all the secrets that I find entangled up in this structure. And that inspires me, I think, in a way that's much more analogous to how an artist or a writer is inspired by by painting or by words. And that's my relationship with mathematics.
In mathematics, it is a statistical fact that there are more men than women working in mathematics. But in my opinion, it's about the participating girls. More or less in every year are around 10% of all the IMO participants. 90% boys, 10% girls. In some countries, there were years when out of 6 students, 3 were girls. In other years, out of 6, there are no girls. It changes from year to year.
This year, it's almost a record. I think there are 90 participating countries. Now, there are over 500 contestants, but only 39 girls. And they come from 32 countries only. So girls at this level of achievement in mathematics seem to be very few and far between. And it's very difficult to say why.
I don't think I ever had it in me to hide my enthusiasm for math or hide that I thought it was cool or hide that I was willing to do math in the evenings or the weekends. I just loved it too much.
Melanie was sort of a legend anyway, because she was the first female on a team that's traditionally always been male. And so she sort of broke that barrier.
My father had passed away when I was a baby, and he had been a math teacher, and my mom had been a Spanish and French teacher. And so I think she thought it was important to teach me the math to represent my father, even though she liked teaching the Spanish and French better. I never thought of myself as a math student, particularly more than any of the other subjects, until I was in middle school. And there a teacher pulled me aside and said something like, "We're going to do this math competition this weekend. Will you come with us and be on the team?" And I won the city competition, first place, as a 7th grader, and this was for 7th and 8th graders. And we were totally shocked. I had no concept that I was, as good at math as it would take to do something like that. And so that qualified me to go to the state competition. And so I went to the state competition, as a 7th grader with these 8th graders, and I won first place in Indiana. And so that qualified me to go to the national math counts competition with Bob Fisher, who was the Indiana State math counts coach, who I think was a big player in my early success and interest in mathematics, because he helped me out a lot and gave me a lot of problems, which is how you help young mathematicians, is give them lots of problems. And so that's how the math counts was really how I got a sense that I could do math on that kind of level. And actually, before I attended the Math Olympiad summer program for the first time in 1996, I got 2 letters in the mail, postal mail back then, and they were from two women who had been students at the program the previous 2 years. And those two women had each been the only female at the program their year. In my year, my first year, there were two of us, two women. And so those two older women each wrote to the two of us, and they just wrote us long letters about their experiences. And I think theirs were both harder than ours, being the only female, and some of the things that had happened, and some of the boys who had been particularly annoying, and some of the things to watch out for, that some people would be really obnoxious in classes, but that didn't necessarily mean that they were that smart. After my junior year, I won the USAMO. I tied with someone else for first place.
She called up the other 11 winners that she knew, probably through the Math Olympiad summer program, and said, "You must wear a tuxedo to this." So these kids all dutifully went out and rented tuxedos, and then she wore a prom dress. She's an organizer.
For me, the first day of the competition in Taipei was very, very hard. Mathematically, I mean, I ended up actually, I did okay on that day, but I didn't realize how I was doing at the time, and I felt like I was doing poorly. And I found it a very stressful experience, even though I'd had a lot of training at these programs. I mean, people knew that I was the first woman to be on the American team, and I felt like everyone wanted to know how I was going to do. And I felt like I had screwed up the first day, and that's hard. I mean, it's hard at the IMO. This is a huge thing, moving from the first day to the second day, because you need, I mean, the coaches have a huge responsibility getting kids in the right energy. You don't want people to go in overconfident on the second day if they did well on the first day, but you don't want them to go in depressed and feeling like they have no chance. And so, you know, this is hard, and, you know, made it to the second day, and then at least it was over. And I, you know, I didn't feel great about it. I had felt really positively taking, say, the U.S. Math Olympiads that I had taken here at my own school, but, you know, I didn't feel great about it. And it turned out I did better than I thought, and I got a silver medal, and in fact was very close to gold. I was 1 point away from the gold cutoff, and so that was a very good showing. This IMO in '99 in Romania was turned out to be one of the hardest IMOs in years. But we didn't know that, and you know, you don't know going in that. You're sitting there with the problems, you're not talking to anyone else, and you're not solving them. You're not even sort of solving the first problem or some easy problem that you think you're supposed to get. And so it was very stressful. We were all pretty upset, but then when I came out of it and I talked to my team members, they all were really upset too. And that's a little bit reassuring, actually. The U.S. Didn't end up doing as well that year. I think we came in 10th, and so there was a little bit of disappointment about our performance.
And 2005, she became our deputy leader, and again she gave, you know, wonderful lectures to students. You know, when she teach, you can feel she really bring her heart out to want the team to do well and want the students to learn more. And again, the team performed very well.
Melanie Wood has been sort of a role model for me. I mean, she was in college when I started doing math competitions, so, you know, I've been, like, I mean, following in her footsteps in several ways. Mostly it was just that she is a very enthusiastic person, and her enthusiasm is infectious. Middle school was when I started doing academic competitions. I mean, I did math counts, but I also did spelling bees, and I actually went pretty far in that. And so it was really only when I got to high school and when I got to Olympiads that I realized that mathematics was what I wanted to do. I enjoyed preparing for spelling bees, but I really didn't enjoy the actual spelling bee experience because it's really stressful. Most of the time you're just sitting around watching people spell words. Sometimes they get it right, sometimes they get it wrong, and every so often you have to go up and spell a word yourself. And that's pretty stressful. But with math, you're spending the same amount of time, but you're working on math all the time. You're thinking about math all the time. Sometimes you just have to do annoying computations, but a lot of the time you really get to play with the math, and try and figure out something clever to do it, wait for inspiration to strike. I really had not expected it, but I ended up at MOP and I felt when I got there like, you know, I was the least prepared of any of the students there. It was really exciting to be there and to be around all these people who knew all this math, and some of the math lectures there really, you know, changed my life and made me realize that this was what I wanted to do. I knew I was, you know, the second girl and it was to go to the IMO, but I don't really think that changed the pressure all that much. As a kid, I was, you know, attracted sort of by the clever tricks you could do. I mean, I like to look smart, but I mean, as I've gotten older, I mean, I still like really cute tricks. I still like looking at really clever ways of doing things, but I also just really like the experience of seeing a problem from different directions, or just seeing mathematics from different directions and seeing how the different directions fit together.
Sherry Gong. Sherry won a silver medal at the 2005 IMO in Merida, Mexico for the U.S. team. She competed at the International Mathematical Olympiad in 2004 for Puerto Rico and received a silver medal. She placed 12th nationally in the Geography B in 2002 and was a member of the 2005 USA Physics Olympiad team.
So every year at MOP in my class, because they usually divide it into like 2 or 3 classes, and I've always been the only girl in my class. So this is gonna sound really cheesy, but like I miss MOP because it feels more like home. At MOP, I felt like I could connect with people instantly, whereas at school sometimes it takes a while to really put yourself on the same wavelength as one of your classmates. I get really nervous before competitions. I think I get more nervous than most people do, and I guess that's something about me that I guess I don't really like that much, but on the other hand, like, I feel like sometimes being a little nervous makes the competitions more fun.
To get more girls participate in math, science, you know, extracurricular activities will help them for future scientific exploration. And doing these kind of math problems help them to, you know, understand how to tackle problems, how to play with problems, and how to enjoy this process. So to build a program to fight against the social pressure of, oh, if you are a girl, you don't have to be great at math. You need to give girls more opportunities to attract them, to stir that interest.
When people ask me, you know, why aren't there more women? How did you make it? I feel like I had everything aligned, that the stars were really aligned, that I really had all the support I needed at all the levels. I had a mom who is incredibly supportive of everything I did, but never the least bit pushy or with any expectation that I do anything, and that was wonderful. And I feel like that it worked out for me because I had all of these things, and that if it had been impossible for me at school to be a cheerleader and do theater and do math, at some schools that just socially isn't possible. This was a small school, so lots of people had to do lots of things, and so you could do it. But if I had been at a big school where socially that just wasn't possible, I would have had to make choices. And so that's why I think in some ways that I was an exception, because I had a lot of things work out for me, and I was really lucky. I mean, I worked hard, but I think I was lucky.
I don't know how good she is at math because she hides her mathematical knowledge and she really doesn't let it out.
I don't hide it. Seriously, everyone's like, oh, I know you can do better when I can't.
She can. She has potential.
I have potential. But I can't because, seriously, I can try my hardest on a test, I'll get a C or something.
She has a lot of potential.
she's very talented in math. But I think it's interesting because Gabby doesn't think she's talented in math. She thinks she doesn't know math, she's not good at math. So it's kind of interesting, she doesn't seem to have a special interest in math, even though she's very capable.
It's a mutual hate relationship. Just.
It's one way.
Math hates me, I hate math. I can't do it.
What can I do to those 12 or 13-year-old girls who may be good at math but don't realize like how much they can do? Most importantly is just to help those sorts of girls find a community where math is appreciated and where other people like math. You can get a lot of girls if you can get the right people interested and build up the right sort of community. Building up community is just a very important thing, I think. There's this all-girls math competition that's been held for several years in China. A few years ago or so, they started making it international and inviting teams from other countries. And so this is officially the first time the U.S. is sending a team.
I'm here today waiting in the San Francisco airport at the International Terminal for our group of 8 girls who we sent to China to compete in the Girls Math Olympiad. They came back with 5 medals. We're really excited. Sherry Gong came in at first place. She tied for first place and got a gold medal. Wendy Hu came in with a silver medal, and we have 3 bronze medalists.
So this year, around February or March, we were contacted by MSRI and Zooming saying that 8 of us had been selected by our 2006 USUMO scores to the top 8 girls had been selected to be on a team that would represent the United States in the China Girls Math Olympiad. And so I think all the people who were invited agreed to go.
So we are very fortunate to have 8 solid girls wants to do this. And to help them prepare this, we need to find a math camp for them to do this. So this year we choose Awesome Math in Texas. So they had 3 weeks over there training and working with Alison Miller, one of our leaders, and she was there living with 4 of those girls.
And then we traveled to China. First we did about a week of sightseeing, then we went to Wuhan for the actual competition, where it was 2 days of competition, and then we just traveled around, did some more sightseeing, and now we're back.
It's kind of like the International Math Olympiad, except that it's all girls.
So at the end, Sherry tied first, and Elia also did very well. So for other girls, they feel like they can compete with them too. If the opportunity is there, we will get more interests, and more girls will be part of this.
The IMO started in 1959 and kind of comes out of an Eastern European tradition.
The first IMO was held in Romania. The Romanian Mathematical Society decided to invite teams from the neighboring, mainly socialist countries of that time, teams of 8 students, to participate in an international event. And that was duly organized. At the end of it, the people who took part in it, in particular the teachers, so the leaders of the team, told to each other that hey, this is quite a good thing. Why don't we do it next year again? The year 1967 was another milestone in IMO history. At that year, it was organized in Yugoslavia, which existed at that time. And you see, Yugoslavia was a somewhat more open country at that time than the other communist bloc countries. So they were in a position to invite some countries from Western Europe, like Italy and France.
By the early 1970s, most of the European countries were involved, and elsewhere. There was some thought in the United States that the United States ought to get involved in this, but actually opinion was divided, and there was a woman named Nura Raines Turner who was really sort of beating the drum for the United States to get involved in the International Math Olympiad at some level. And she wrote articles, and the influential articles that appeared in the American Math Monthly about why the United States should compete and what this would mean and why we should do it and so forth. And finally, The Math Association of America decided that, yes, they would sponsor a team, and the United States fielded its first team in '74. That year was in East Germany at that time. And there was a lot of predictions that the United States just wouldn't do very well because we didn't have that kind of problem-solving tradition that the Eastern Europeans do, and we didn't have a lot of experience. But actually, the team came in second nationally scoring that year, so that was sort of a big success. We've been involved continuously ever since '74, usually scoring somewhere in the top 5 or top 10. We've had some real spectacular years. '94 was the year that we had 6 gold medals, scored first.
In the U.S., we're really looking to come in the top few places, and so we have a very rigorous training program, and we make a lot of our decisions based on strategizing to do very well. And other countries that may be coming in 20th is a good year for them, they can have a different kind of program. They can have a much more friendly program, much more relaxed program.
There are some countries, and Hungary is one of those countries, where we have a very long competition tradition, dating back to the 19th century. We had our first nationwide mathematics competition for high school students organized back in 1894. And we have a very good mathematics journal, which is again more than 100 years old. And all the mathematicians who started their career in Hungary, they all agree that these competitions and the journal were a very strong influence in the start of their career.
I think many countries has got very strong preparation, or big country, many people. So to be in the top 3, it's too hard for us. China is usually unbeatable.
Everybody know during the 60s and 70s in China there's a cultural revolution and caused so many chaotic situations. During that time, not many people were studying at all. And only after '78 they start to rebuild this education program completely. And at the beginning, all the old education materials are really outdated. And the math education, well, they do emphasize math, but you know, the problems are 80 years ago. There's nothing new. So I think a few math contests helped them a lot. So they studied the AMC tests. They translate many of them into Chinese, and to build that interest of getting new ideas, of new problems, new math. And then also American Invitational Math. They participate in the '80s, you know, and that totally changed the Chinese math education.
Asia is fairly well covered, South America about half, and Africa very poorly covered. And as an African, as a South African, that actually concerns me, that we have at this IMO, South Africa, Morocco, Nigeria, and Mozambique. And that's 4 countries out of, I think, 55. And that's not good representation at all. The reason is, I think, lack of good preparation by African countries, their nervousness about coming here and not performing well, and finally money.
Now, in other countries, this concept of a nationwide mathematics competition was unknown a couple of years ago. There are many such countries. And when they hear about the existence of an IMO, and it is more or less a prerequisite for a participation to have a national competition, because that's the place to choose the national team who will come to the IMO. So these countries have started their own national competitions, which then have a wide influence on the whole educational structure. So if teachers and students are aware that there is such a thing, we can participate, it makes fun, it's a good way to development. And I can even travel with that if I am good enough and get to faraway exotic countries as an IMO participant. This is a great challenge. And experience shows that it raises the general level of mathematics education as soon as a country starts organizing such national competitions. It's a very good idea.